seem to mess everything up, Logan. We good, we good. We're locked and loaded with the spider. Hello, how are you all doing this evening? Robot? Give me a second. Better? Yes, Tortilla, surely a first time and not a repeat of 15 minutes ago. Hello? Beep boop. Nope. Nope. Still robot. Okay, what about now? Still. Ugh. Um, 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 um. What about that? Or how about now? I think this is probably pretty quiet, but it might not be as robot-y. Where are we on? Where are we on this right now? all? Am I speaking to myself? Okay. I don't think you can hear me. Hello. But still. Are we connected? Still robot. Ugh. Hello? Okay, are we saved? Am I still robot-y? I can't believe I can't believe that exclamation point fix worked. That's wild. But okay, we're caught up. Normal. Great. Hello, everyone. This is regular Evan and not robot Evan speaking. How are we doing tonight? Aloka, Russian, Alexis, Roxers, Roach. Hello, everyone. We are back and we are in business. Am I? We're back? Back for reals? Still here. Okay. The technology is out to get me. So hopefully we've hit our quota for issues. I'll knock on wood just to so we hopefully don't jinx that. How's everyone doing? Thank you all for being here and welcome to another fantastic week of Alveus Bug Hunt. One Petrus, one of your friends has done a lot of work with whip spiders, and we're trying to figure out if you guys knew each other. I've never specifically worked on those, Petrus. But I have found them out in the wild before. You know, in Arizona, they were local, so I was able to go out and find them there. But no, I've never done any professional work with them, I should say. This guy is schmoovin'. For what we expect from these dung beetles, that was like a very coordinated walk across the hay. He's now going to burrow, probably, under this little bit of hay here again, so we can't see him. But that was probably the most coordinated dung beetle that we've ever had. Oh, back up and running. He's everybody bowling over these ants like it's nothing as well. Look at him go. So for those of you unfamiliar with who we're looking at right now, this is Digitoanthophagus gazella. This is the gazelle dung beetle, which unfortunately is not native to Texas. But those big kind of forward projecting and spiky front legs are a pretty characteristic feature of dung beetles because they use them to break apart the dung that they are digging in order to then dig a hole down to take dung for their babies. As we were looking at this one from turns again, you'll be able to see it. This is actually a male, and he has a pair of horns, or yeah, a pair of horns like right above his head. So there are actually horns on this dung beetle that he would use to compete with other males for access to the dung resource and for access to females. However, there's a really cool method that some dung beetles will use to circumvent the need to fight for access to these dung tunnels. So Digitoanthophagus gazella is what we would call a tunneler, which will take dung and then basically dig straight down under the cow poop or whatever poop source that they found, dung down into that tube with them. They will then find a female who will go down and lay eggs in the tube after they've mated. However, the males will then stand there and block the tube. So they have mated with this female. They're protecting it from mating with other males. And so they will stand at these tunnel entrances and use those horns to fight. They will spar just like a cow or a deer or a bull, whatever you want to call them. And so they will lock horns and try to fight with each other. But if you're a small male, the size of your horn are determined by access to adequate resources as a larva. Meaning that if you are in higher quality dung or you have access to more dung as a baby, you will have more energy and more resources to put into developing larger ornamentation. But if you are in a bad poop pile or something not as nutritious, you don't have enough energy and calories to basically put into that fighting resource, so you will oftentimes have less success trying to access females. But there's a way around this, right? So there's a tube that's going from the dung down to the female, and the male with the large horns is blocking your access to this tunnel with the female in it. Well, what do? You sneak. They're called sneaker males because rather than fighting with the large male who's actively guarding that tunnel, they will sneak around to the edge of the tunnel and basically dig a separate tunnel that is parallel to the original tunnel. And eventually, once you have passed where that is guarding, you will dig horizontally and connect these two tunnels. And so you have now just circumnavigated the male who is blocking the tube, but now you have access to the female who's at the bottom of the tube. So there are these sneaker males, as they're called, that will go around and avoid the confrontation, but still be able to mate. Still be able to mate and pass on their genes, even though they wouldn't typically be successful in the male-male competition realm. Now, this is different than how it would work with actual mammals, say like deer. Deer, the larger horns, or the larger antlers, excuse me, are genetics based. So larger antlers come from deer that have large antlers. And there are people that will do like selective breeding for deer in captivity, just see how crazy deer antlers can get. Which is kind of gross and weird in my opinion. But that is not environmental based. That's genetic. So genetics with big antlers will pass down big antlers, but in insects, I think it is always resource availability. Horn growth. Just writing my notes for the recap a little bit later, and also sneaker males. So you can do a similar thing. You can provide like less dung to an offspring and get smaller males than you have with larger males. But it's not just dung beetles that do this. This is a size thing that is consistent with food quality across insect groups. And you particularly see this in wood-boring insects. Old Russian. Thankfully, you don't need to. I keep notes for all of this. Someone wants to ping the bug cord for me. We have a Discord channel where I post the chats recaps. So any of these concepts and links that I want to send or articles that I mention, there's a channel in here going back for several months now that has notes on all of the chats. Most of the chats. I think I've maybe missed a week or two. But there are notes basically going back on chats. So you don't have to keep them yourself if you don't want to. You can just join the bug cord here and see months and past discussions. Anyway, the food resource idea comes around, like I said, in wood-boring insects a lot. So insects that as larvae feed in wood. When there is a fresh tree that is downed, there are more nutrients in that tree than there are if it's like really old and dried out and kind of like an old fall from the year before. And so the larvae that are in better quality wood will often come out orders of magnitude larger than some of the individuals that come out of poor quality wood. And there are some species of wood-boring insects that is less than a centimeter. And I have also seen one that was over 2.5 centimeters. So for you US folks, that's a little over a 1/4 inch as opposed to a full inch, that were identified and keyed out and confirmed by an expert to be the same species. but the size difference would be the size difference was due to the resources available where that larva was laid. So it's not just within the same tree, there is some differentiation. Some places might, but I'm talking about like two separate trees where like mom decided to plop your egg down, and if it wasn't in a very good tree, unfortunately, you're going to be a little bit small. Would, thank you, Donkus. Would I say that the older larvae have a natural advantage then? Not not necessarily, because tree decomposition or tree nutrient availability in general is not consistent across the tree. With have already died, but in a living tree there are still hot spots where there are more and less nutrients. So imagine a tree falls over and it's like baking in the sun. The top layer that is facing the sun is going to decompose a lot faster. Those mushrooms and fungus and other insects that are in there are going to be able to break it down super quick, but the stuff that's maybe underneath the log maybe will not have quite as much insect activity. On the other hand, if it's too warm and too directly in the sun, the insects would bake. And so then, in that case, the underside of the decomposition is going to be happening because there's insects that are able to survive down there. So when a log falls over, there are a lot of factors that kind of help with that decomposition process. And part of that are insect larvae that are in there breaking it down. So even within the same log, there's not going to be the same amount of nutritional availability depending where mother beetle has laid your egg. So it doesn't always necessarily mean that the older larva has a natural advantage. It's the ones that happen to be laid in the right spot. And because they can survive in a variety of habitats and like a variety of what am I looking for here? Oh, a variety of circumstances, right? So as the mother beetle, you are just trying to lay your eggs to pass on your offspring. They're going to look for excuse me, sleepy tonight. They're going to look for the best available resource and the best available place to lay that egg. So they'll find one and they'll go, okay, here's good. I'm going to put one of my eggs here, and then they'll fly along for a little bit, maybe find a better egg or a better site, lay an egg there. And so even though that other one was laid before you, it may have been in a not quite about that. But I do know that there is quality issues in terms of forage and food resources available to the larvae that do tend to play a role in either adult size or in the cases of things that do have horns or ornamentation of some sort, generally higher quality larval food means that they can produce larger. I don't have children, so I don't know about that. But yeah, kind of the same. setting them up for success, right? That's part of the goal. We're saved, we're back. We're blinking. Stay alive, chat. Stay alive. I saw somebody link orange spotted flower moth. That's very cool, kissing Wookiees. Has anyone else found any? Has anyone besides Roach gone out spider sniffing since last week? Has anybody found anything that they want to talk about? Logan sniffed a ton of spiders. Excellent. I hope they smelled good, Logan. For those of you maybe not aware of what we're talking about, not actually sniffing spiders, but a lot of spiders, wolf spiders in particular, will have a reflective shine on their eyes, and if you put up to your nose, the angle of reflection of those eyes makes it so you can see them really well. So you put the flashlight up to your nose, and you can use that to try to find spiders at night. And colloquially, people call it spider sniffing because you're sort of using your nose to try to locate the spiders. But they don't actually have an actual smell, as far as I'm aware. Okay, let's see what y'all got. Kit Cinnamon. 2 harvestmen on your porch. Excellent. Sort of hopper on your blackberries. Excellent find, but hopefully not one that's feeding too much on your berries. Rescuing stink bugs who decide to cohabitate. Woolly bears. Oh, love bugs. Nikki, 'tis the season, am I right? Don't worry about repeats. These, all things considered, we're going to consider these 2 separate streams. But yeah, love bugs, for those of you in the southeast, I bet, is the time for love bugs, or these little bibionid flies, or march flies as they're sometimes called. They pair up and they mate, and they don't really unhitch. So once the male finds the female, he will ride around with her flying, mate guarding, essentially making sure that nobody else is able to mate with that female. And that's another strategy. There's no really way for a male fly to sneak in because they'll directly attached to the female. So that's another way that some insects will try and prevent other males from mating with the female that they have already mated with. Tortilla stepped in an anthill. That's a bummer. Wolf spiders, excellent. Rabid wolf spiders, very exciting. That is referring to Rabidosa rabida, the species name. Not that spiders have rabies. They cannot vector rabies because rabies is a mammal disease. People get kind of bent out of shape about the rabid wolf spider just by the name, but rest assured, cannot transmit rabies. House centipede. You got rid of it and it killed your vibe. I hope you mean the vibe of having a centipede around. The vibes are better with centipedes, in my opinion. You guys are doing great. Longhorn beetle flew into your apartment and landed on your roommate's arm. You guys are seeing a lot of cool bugs. That's very exciting. And a lot of you are seeing spiders and aren't reporting being that afraid of spiders. So hopefully some of our positive bug propaganda here is working for you to help overcome some of those fears. Monarch. Excellent, excellent. Centipedes, yes, yes, yes. Fruit flies, orb weavers. A lot of diversity. I remember just a few weeks ago, at the beginning of the summer, we were waiting for everybody's bugs to pop off. You know, we are coming up here to the end of summer. It's already September. We're down into fall. So maybe our bugs are going to be slowing down again, but hopefully not too much so we can keep doing these. Spouse Pro Bug. Excellent. Ooh, mantis and a lizard. I missed that clip. I'll have to check that here after stream in just a second, Erickson. Thanks. Nim, that's fair. They said that I just don't like the idea that spiders can bite. In general, anything with a mouth can bite. So, that doesn't just go for insects, that goes for anything as well. And your chances of getting something nasty from a dog or cat bite are exponentially higher than the likelihood of you actually having an adverse reaction to a spider bite. There are only two genera of medically significant spiders in the US, and those are going to be your recluses and your widows. There are multiple species, but the ones that everyone talks about are going to be your black widows and your brown recluses. Now, there are 3 different species of black widow in the US. There is a western, there is a northern, and there is a southern. But there are also red widows in Florida, and there are also brown widows across the southern border of the United States. Not as much venom comparison has been done on red or brown widows, but black widow, the issues with their venom has been like severely overblown. They are medically significant, but in general, with healthy immune systems and no other it's going to hurt. It's not going to be fun, but it's certainly not going to kill you in the way that most of the media would have you think. So I understand the hesitancy, but anything can bite. And way, way, way more people go to the hospital every year from dogs or cats than they do from spiders. So stick around if you can. I used to be very afraid of spiders myself, but then I took a little bit of time and I purposely sat down and tried to learn more about them. And after reading a lot about them and actually seeing them and doing my best to appreciate them from afar at first, I've kind of swung completely the opposite direction, and I am now. So we're not trying to convert anyone necessarily, but having more positive thoughts and positive reactions to spiders is one of the goals of these kind of bug hunting streams, you know, just getting people a little bit more comfortable with them if we can. Pollinator Park wasn't scared. Excellent. Icepod, Springtails, Millipedes. Orchard Orb Weaver. False Widow. Roxers, that's a great question. So Roxers asked, that actually made me think, is a centipede bite called a bite a sting or something else? I know it's modified legs that do it. That is something that we have talked about before. But for those of you that might not remember that, the thing that actually does the venom delivery in a scorpion are the front modified pair of and so they're super modified to deliver venom, but they do function in feeding. So because it is venom delivery from a ovipositors or stings, I would personally say bite. And I'm not really sure why. Because stingers, when I think of insect stings, I'm thinking of ants, bees, and wasps, which sting through the ovipositor, which is the egg-laying tube of the female. But you also have scorpions, which have at the tip of the tail, which is unrelated to oviposition. It's unrelated to laying eggs like it is in Hymenoptera in the insect world. So those are like the two groups that I would say sting. I would say bite for centipedes, but I don't really have a good justification as why that wouldn't also be a sting. I can look that up and see if there is a real reason here. Because that is a good question, and I don't know. Y'all make me think. That's great. Every week you have very good questions that some stuff up and learn along with you. And then, yes, this here is one of our big wolf spiders. The spider sniffing that I was just describing a few minutes ago would reflect this same eye shine that we're getting right now from the IR on the cameras. So wolf spiders are nocturnal and they are active predators, so they use their vision to be able to track down what they're going to feed on. And they have this special lens in the back of their eye called a tapetum lucidum, which is the same thing that gives the reflections in like cat eyes, that same glow at night. And so because of that, they're able to light at night and still be able to see in order to be able to hunt in the dark. And the reflection of that with the IR light and with the flashlights, just something neat that we're able to see with the cameras that we're able to talk about. So I know it comes up a lot, and I know the dung beetles come up a lot, just because those are both very common insects here at Alveus, but there are new folks here every week, so it bears repeating. I apologize if it feels like it gets a little bit too repetitive, but we do our best to switch it up here if we can. Bubbles, not really. I'm not that kind of doctor. And efficacy of medicine and reactions to bites and stings tend to be different for everyone. So, not something that I'm comfortable getting into. Because what works for me very well likely might not work for you. So, unfortunately, you might have to try out a few things as stings and stuff come up. Oh, Wookiees, that's sick. Wolf spider with an egg sac first try. Yeah, not a problem. Oop, there she goes. A little bit of movement there. Bye, spider. Fish Command, hello. Welcome in. Welcome to Bug Hunt. Ooh. I can't tell what those little things are crawling on the platform. But there's some other little things going on in the back there. They might just be ants. Russian, it depends on the spider. excuse me, if they're on a stable enough ground source, they're able to feel that and maybe feel prey items coming towards them. Wolf spiders don't do this, but tarantulas will. They will actually set like drag lines down on the ground, so they will put silk down on the ground, not make a web per se, but they will lay down silk so that things will touch it and they'll be able to feel when a cricket or other insect walks by for them to try to feed on. So I am to the time it's just them trying to get a handle on their environment. But it's also possible that there might be something larger walking around them that they're trying to stay still to not be found by. That was a wolf spider, Goldman, not a recluse. Recluses are much, much smaller and don't have nearly as much patterning on them. Oh, that was a lacewing. That was a fantastic... Oh, Fish Command, who are you? I thought you were a new chatter, because, yeah, you changed your name. Your name didn't sound familiar, but welcome back. Hello. That was a lacewing chat. So we have seen those before. There are these little green things, very, very delicate-looking wings. They're called lacewings because they have a ton of veins in the wings that make them look like a net or like very, very fine lace. So that's where they get that name from, and that whole group, so antlions and owlflies, are also in that same grouping of lacewings. London Brawley, 21 months. Welcome back. Oh, J. Julie. Okay. I have seen your name. Yes, yes. Unrelated. I've always been curious about there are certain bees that bore into wood. Yeah. Very aptly, those are called carpenter bees. They bore into wood. The females are the ones that do the boring into the wood. And it's to lay babies. They will dig these little tunnels, which they will then stock up with pollen and a mixture of their saliva that sort of makes it into like bread dough. And it's like a soft, squishy thing, and they do call it bee bread. It is a mixture of pollen and saliva and nectar that they will pack into the bottom of one of those holes that they're digging, and then they will lay a larva on that. And then as that larva feeds on that bee bread, and they will develop and then come out of the wood. Leafcutter bees will do the same thing, except they will deposit that bee bread inside of the little cut up and folded leaves and flowers that they tend to use. But yeah, carpenter bees, that's just their preferred nesting material. Unfortunately, that does have them chewing into people's like decks and things like that quite a bit. But unless you have a super, super heavy infestation of them, and I very hesitantly say infestation, if you have a lot of them, you would have to have thousands per like deck beam to actually cause any. And part of the reason for that is that the male carpenter bees are super territorial. If you've ever had a big bee that's like kind of hovering at you, that's usually going to be a male carpenter bee trying to defend territory of some sort. One way that you can tell the males from the females is the males have a little white spot right on the front of their head between the eyes. It's their clypeus, which is sort of like the upper lip portion of the insect. But the males in carpenter bees, it's bright white. In, white or yellow, but it's a very distinctly different color than the clypeus on the females, which tend to be male buzzed at you. They're generally defending territory, and because of that, they will defend territory from other carpenter bees as well. So there's really not a risk of having enough of them to do damage. So yeah, it's just their preferred nesting, their nesting materials. Invasive giant reeds, but on the plus side, ton of native solitary bees. Yes, that is another thing. Dried grass stems and things like that are great habitat for the smaller solitary, like native bees. Things like sweat bees will either dig tubes down into the ground, or they will use stems of cut flowers or grasses or sticks or anything that they're able. So leaving that stuff is also very helpful for pollinators, which is why oftentimes when you see like bug hotels, there's all these little sticks and bamboo shoots and things like that, because those holes make good cavities for native bees. Store-bought 99, 11 months. Thank you. Welcome back. Probably a dumb question. Never a dumb question. Insects are so varied that you can talk and say something interesting about just about all of them, because there are so many exceptions and oddballs that do weird stuff. So it's almost never a dumb question when it comes to bugs, because there probably is a case that we could talk about. Do bugs ever get overheated in the summer? If so, how do they cool off? Yes, they do. In the tropics, the really big Hercules beetles and things like that will almost always fly between 3 and 5 in the morning. And the reason for that is because flying when you're such a large-bodied beetle is metabolically expensive, meaning that their muscles are putting out like a ton of heat energy as they're trying to fly. And if they were to try to fly during the day, when the sun is out, they would very easily overheat. So they only in the middle of the night when it's coolest. And having lived in Arizona for the past 5 years until just a few weeks ago, insect activity definitely is not at its peak during the day. So the general answer is that a lot of them just won't be active at that time, which that's the easy answer, right? It's too hot to be outside in the middle of the day, so they do their foraging either at sunset or in the mornings before it gets too hot. But they can also cool off with water. You will see a lot of different insects going to drink from puddles or other water sources, or trying to find something like fruit that has a lot of liquids with. Take a break, replenish some of their energy from doing that. But they can also pant to a certain extent. There's a lot of insects that you will see them after they've done a lot of activity in some way, whether that be a male-male fight or a very long flight or something like that, where they will stand there and they will pump their abdomen. And what they're doing is pushing air in and out of their spiracles, which are those little holes on the side of the body that they breathe from. So just like a dog, when it's hot, it's panting, it's trying to get all of that hot air out and evaporate that liquid on the tongue, so it's sort of sweating to cool down that inner temperature. Insects will do that too, where the built up carbon dioxide and the hot air inside of them with the cooler air from the outside. So I don't think that was a bad question at all. That was actually a pretty good one. Bee tenants forever. Yes. Laying out against your windows. Bee hotels. Yeah, I can answer that, Roach. Let me catch up on chat, but then we will get to that in just 1 second. Ooh, everybody's answered it for me. Y'all are learning. You pick up on the things that Maya and I teach you, which is great. Bee hotels can help, but they do need to be properly maintained, because if you think about what you're trying to do with a bee hotel, which is going to be mimicking those native nesting areas, if you are a stem of a hollow blade of grass, that's generally within the course of a year going to get knocked over or grazed or something. And once a bee has built its nest in there, they generally won't reuse those tubes. So, one of the big things that you need to do with bee hotels is make sure they're kept clean, and the oftentimes has like a plug at the back that's native, or that's, a part of the bamboo. But if a bee does build a nest in there, it needs to be cleaned out every year, because there's a chance that the old stuff can rot and promote mold growth or pathogens or harbor parasites like different kinds of mites and things like that can get nasty for the bees. So there's certainly nothing wrong with them, but they do take a little bit of upkeep, more than people think they do. So there is some good to it, but if they're not properly taken care of, they can, in the long term, actually harm the bees. But yeah, they're good. Otherwise, I have some put out around my house right now. I didn't build them, but you can definitely look into them. Sleepy VTuber, we all love Georgie. Yes, someone else got to it, so you got your answer, but this is a special segment on Wednesday nights where we look at bugs with the cameras, but Georgie is a star, and I don't fault you at all for wanting him up. Yes, kissing Wookiees. Yes. Another Katie did. So, Grasshopper versus Katie did. Donk texting, yeah. So it's looking at us right now, which is super helpful for what I was just about to talk about. Katydid antennae are placed very, very high on the head. And so you're looking at it face on right now, which is so helpful. You can see that the antennae are basically coming off of the top of the head right between the eyes. And now that it's turned back, I, of course, can't talk about it anymore. But if we go back and look at that at the VOD, or if somebody clips that when it was turned around towards us, the antennae are also very close to touching where they're attached to the head. So not only are they placed up very high, but the actual bases of the antennae, where they come together, is very, very close. These other groups, like grasshoppers, which generally you wouldn't confuse with katydids, because katydids are the ones that have these like absurdly long antennae. These ones, the antennae are very clearly longer than the body. So katydids are sometimes called long-horned grasshoppers, but they're actually in different suborders within Orthoptera, which includes all of your things like grasshoppers, crickets, and katydids. The difference between the two suborders, so you have crickets and katydids are in the suborder Ensiphera, which are going to be your quote-unquote long-horned. Typically, those antennae are going to be long, like as long as, if not longer than the body, or they're made up of more than 30 segments. So if you zoom in on these antennae, they're made up of little tiny rings called antennal segments, and there are kissing Wookiees W clip. Thank you. There are certain things that are in the long-horned grasshopper grouping, like mole crickets, which are a type of orthopteran that tends to dig and burrow underground. And if you think about it, having super long antennae is a hindrance underground, because they could get caught on all kinds of stuff. So they have relatively short antennae. The segments are very small, and there are more than 30 of them on those antennae of those other groups. Grasshoppers, on the other hand, the short-horned grasshoppers, like your bog standard grasshopper, there are monkey grasshoppers and a bunch of other things. Those are all short-horned because they are generally less than like a third of the length of the body. But even when they're a little bit longer, they're not made up of 30 segments. So they are closely related, grasshoppers and crickets and katydids, but they do split at some point based on that antennal length. So this one has uber long antennae. This is a katydid. This is the short-horned grasshoppers. They are some long antennae. You're absolutely right. Wookiees, yes. Yes. That is a behavior that we talked about last week called stridulation. What's essentially happening there is that there is a scraper on one wing and a bunch of pegs or a file on the other wing. Yes, Flumgoon. There is the file and there is the scraper. And they will rub those back and forth, and the it's like if you have down the teeth of a comb to make that like ting 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 noise. That's essentially what they're doing, but very fast. Crickets do it the same way. We talked a little bit about stridulation last week, but there was a really good video that I can post of a cricket doing it that I know I've watched in my entomology classes before that shows exactly what's happening, and it's slowed down a ton. So you're able to actually see the wings going back and forth against each other. So yes, this is a male katydid. Again, males tend to have even longer antennae than the females do because it's extra surface area for them to be able to pick up hormones and other chemicals that females are putting out to ultimately be able to mate. So male insects in general have larger antennae than the females do, and he's trying to call in or let a female know at least that he is available using his little wing strikes right there. Are locusts also closely related? Yes, this should probably be the last question here, since we're about at time, but we can go a little bit later. Logan, if you're still available, since the tech difficulties at the beginning, I am good to stay on for another 10 minutes, 15 minutes or so, to make up for that. What was the question? I forgot the question. Locusts. That's right. So all locusts are grasshoppers, but not all grasshoppers are locusts. So this is a thing that occurs in a couple of different genera of grasshoppers, and the locust is actually the forming phase of a species of grasshopper. And that phase is initiated by repetitive contact. So in nature, these populations build up where there are a bunch of grasshoppers that have their eggs laid in the same place. So when these baby grasshoppers are growing up, they're really crowded in. And a lot of the time, this results in them bumping up against one another and basically touching a bunch of other grasshoppers all the time. And I have not tortilla, but you've caught up to what I was going to say next, is that if you take a brush and you rub a grasshopper's one of these grasshoppers that does have a locust phase, because again, not all of them do, have one of these things that could turn into a locust phase, and you're able to rub the leg several hundred, if not thousands of times, you can actually initiate this morphological change. And so this happens in grasshoppers, and it not only changes their behavior in terms of them like swarming together, moving as a group to fly and find food. The reason why locusts are such a big problem is because there are thousands of grasshoppers in a confined area. They will go to a new spot. Because there are so many, they will eat all of the stuff, and then they will move on as that's why it's like, you know, up to biblical plague proportions, right? Because these grasshoppers will move around and just decimate crops if they go unchecked. So you get them in this locust phase, and not only do they change behaviorally, but they will also change physically. So the locust phase of some of these grasshoppers will oftentimes have longer wings than they do in the non-locust phase. And that, again, is to deal with the fact that they're going to have to fly these longer distances to find food, because basically all their friends are eating them. Is not a separate species. And once that phase has been initiated, it can't go back. So you can't like go to a locust and they're like, oh, we're done with this now. Go back to being a regular grasshopper. But with the right conditions, certain species of grasshoppers can go into this locust phase. So it's not like your emo phase. You don't really grow out of it. It's kind of like a finalizing choice there. And you're not making it per se. It's a physical response that changes like distribution of hormones. And it's a really cool process. And I did a pretty deep dive on these at some point. There are early resources in the chats library already, but I will find them and make sure to post them again for this week, because it is a very, very cool topic. Stuck as locusts. Yes. Predators of locusts. Yeah, lots of stuff will eat them. So it's just a grasshopper, you know? So any number of other insects like beetles or spiders, which I know are not insects, but spiders will eat them. Mammals will eat them in mass. So anytime there's a really huge emergence of insects of any sort, so we see this with the cicadas a lot of the time, the 17-year cicadas here in the US. Those possums, skunks, squirrels, even deer, bears, all kinds of stuff will eat all of these leftover insect bits. And so after you have a cicada year, you will oftentimes see increases in populations of other wildlife as well, because they've had that available food source for them. And so if you're a mama skunk struggling to find your food for your babies, and then all of a sudden there's like a bajillion cicadas on the ground, you're able to eat those, your babies are able to eat those, and then get nice and big and strong. So cicadas and locusts, which are different things, they're completely different insect or locusts and cicadas are different, even though people will oftentimes call cicadas locusts. That is incorrect. But those big food resources don't go unnoticed by the other animals in the area, and in some places people will eat them as well. So the locust plagues or the locust swarms will take down your crops, but you can then catch like a ton of protein if you're in one of the like 80% of countries that eats insects on a regular basis. Just not the US and not Europe. Amanda, hello. she's late, but it's okay. It's Amanda. She's allowed to be late. But yeah, so that's, I hope that was, I hope I didn't miss too many of the locust questions. I feel like I got to most of them. But yes, I will be sure to post references on locust things in the chat's recap for tonight, because it is a very cool system. I even have, I think, at Arizona State, where I just was before I moved to Florida somewhat recently, we had a locust lab, and I have pictures, I think, of the behind the scenes of them rearing them in densities enough that will cause them to turn into locusts. I also have a very funny video. They were looking at flight time and the ability to fly in these locusts. And so they made this really crazy wind tunnel that had a huge fan on one side, and it was a bunch of PVC pipes. And what they would do is they would attach a very small magnet to the back of the locust and a very small magnet inside of the wind tunnel. So they would basically they would go and they would magnetize and basically stick this locust to the roof, and then turn on the fan, which would then signal it to be like, oh, it's windy, I need to fly. And so they were able to look at the mechanics of them flying and figure out how long they're able to fly at a burst based on certain diets and things. I think I have some of those behind the scenes pictures that I'll be able to put in into the bug cord as well. Ooh, we do have a very nice trail of ants there. Lots and lots of ants. This is what's called a foraging column right now. So what these ants are doing is that somewhere on one of these ends of this ant trail, they have found a food source. And that ant then reports back to the colony and goes, hey, everybody, I found food over here, but it's more than I can handle by myself. So everybody needs to come with me here and like help grab a seed or dismember this really big dead bug that we were able to find and take it back to the colony. If you've ever seen A Bug's Life, like the Disney movie, sorry, it's a Pixar movie, at the very beginning, and like the whole idea of those ants carrying the food back, and then like getting messed up by the thing that falls across their path or whatever, is pretty accurate, actually. So they're going back, they're retrieving different pieces of food, and the reason that something falling across the path would actually disrupt them is because they often make these trails with chemicals. So an ant will go out, like, okay, running around to basically refine that trail again. So Bug's Life, somewhat accurate. Ooh. We back? We still here? Saved. Okay. The ants were censoring me. Parakeet, good question. Do they store food in their anthill? Yes, to some extent. So different ants will do different, and it is easier to store seeds than it is to store protein. So ants, harvester ants in particular, feed a lot on seeds, but they will still have to go out and forage through most of the year to get access to protein sources of various types. But there are other kinds of ants that are called fungus-growing ants. And leafcutter ants as well will do this, because the leaves that they are carrying down there, they're not actually eating the leaf. They're using that leaf to grow fungus that then they eat. So fungus gardening ants are really, really cool because they have fungal spores that they will carry around and inoculate pieces of plant. So they basically have these gardens underground that they're growing on purpose fungus. So ants have like sort of developed agriculture, which is neat. They're purposefully growing this fungus for a food source. And so that means that they have to harvest a base for it, which in leafcutter ants is those giant sections of leaf that they would cut. And so other ants will do that as well, bring little pieces back and purposefully grow these fungus gardens to feed on throughout the year. Someone mentioned honeypot ants, which are also very, very neat. Have these special individuals in the colony that are called repletes, Repletes, I think. No, not replace phone. In honeypot ants, fungus gardening. Okay, for the notes. But repletes are specifically individuals whose job in the colony is basically to hold food stores. So their abdomens blow up super big and they are filled with sugary liquid that they essentially then dispense to other ants throughout the year, especially during winter when food sources are scarce. Honeypot ants don't always have individuals that are honeypots. It's when a colony gets to a certain size and they can afford to have workers specifically become food stores. If it is a small colony, none of them will do that. They will just go out and forage like normal ants. Honeypot ants most of the time look just like normal ants. But when a colony gets big enough and is successful enough, they will have these individuals that, yes, Tortilla will hang from the ceiling and basically act as a food reserve for other ants. AMs, that I think their behavior is very interesting, but in general, especially the red imported fire ant, it's definitely not it because it's out competing native ants, and that's no good. We do have native species of Solenopsis, so like that's okay, but I do have a little bit of beef with red imported fire ants. Are termites and ants the same? Vivin, no, they're not. Ants are in the order Hymenoptera, so they're closely related to bees and wasps. Termites are actually in the order Blatodia, which means that that termites are just very highly derived cockroaches, which is really neat. That was something that we figured out about, we, as in the scientific community, figured out about 15 years ago. And at the time was very controversial, but all of the evidence seems to point that way. So they aren't very closely related at all. The thing that they have in common, though, is that they are both social insects, which means that they have overlapping generations, meaning that there are multiple ages of workers or larvae in the nest at one time. They have a reproductive division of labor, which means that there is jobs within the colony. So in a bee colony or an ant colony, for instance, you will have individuals whose job it is to go out and look for food. You will have individuals whose job it is to clean the nest. There are individuals whose job it is to take care of the other. And that is the third section of sociality in insects, is cooperative brood care, meaning that there are individuals in the colony who are taking care of offspring that are not their own. So they have converged on this idea of like a society, basically. But ants and termites, yeah, are not closely related at all. Wyatt, yes, that's also a good question. Can they change jobs and when? Yes. So typically they go through they do change jobs quite often, and it's based on the age of the individual. A lot of them will start off, at least in ants. They will start off taking care of the offspring because no, that doesn't make sense. I think they start basically as like in the colony, janitorial and also like digging. Then they move on to caring for larvae because they've learned a little bit more. But the last job that bees and ants have as adults are going to be foragers. So, like we're seeing right now, the most dangerous place for an ant to be is outside of the nest. And so, if you're sending your youngest ant out of the world, that is the biggest chance for them to get attacked by a predator or eaten or die in some other horrific way. So, they actually, and this sounds morbid if you think about it in terms of our societies, they send the elderly out to forage. They send the older ants who are going towards the end of their lifespan out into the world to forage like this because they have already done their other jobs of taking care of the babies, of building the tunnels, of clearing the nest. And all of this is taking place over a matter of like weeks. An ant or termite or bee queen can live multiple. Termites have some of the oldest or the longest living colonies, with like an individual colony of like one queen living upwards of 30 years. Honeybees, you get about 10 years out of a queen sometimes. Ants can go anywhere from like 3 to 5 all the way up to 20. So that individual, like the queen, lives a very long time because she has other individuals basically taking care of her. But for a worker, you have a couple of weeks, a month to maybe 3 months. So at a month old, maybe you're taking care of the larvae, but then at 3 months old, you're out foraging. Amanda. Okay, we're back. Let me finish my thought here on ants, and then we'll wrap it up because we've gone over our overtime a little bit already. Roxers did make a point that the size difference between soldiers and workers is crazy. Yes, so there are some who are specifically their job is colony protection. So they will go out after they will go out with the foragers, and they will have really big heads or other ways that they're able to protect the foragers while they're out, but they will also stay in the colony in case there's some sort of intruder that will come in. So there are also jobs that come with age, but there's also jobs that come with kind of like caste size. And yeah, Logan, you can see here, or Amanda, I guess you can see here that one is they are teaming up to grab that mealworm that you dropped earlier. So you can see it then. They're going to carry it back in chunks, or they will group carry that back and save that for their food source. So you fed the chickens today. You also fed the ants today. So you can feel good about it. All right, y'all. I think we are going to call it there. Silvera, yes. I think all of the mealworms that they feed at Alveus they come dried. Yeah. Thank you all for being here. As always, it has been a pleasure chatting with you for the evening. I love doing this, so you guys are a big part of this community, and I appreciate everyone coming, even if there are hesitancies about bugs sometimes. We try to work towards that. So thank you all for being here as always, and as always, we thank Logan, our lovely camera operator. The tech issue is his fault, so doing a great job as always getting us in on the bugs to talk. Other things to plug. I have started streaming personally. Tortilla just linked my personal Twitch account, and I have been doing pre-chat chats. So for about 2 hours before this stream happens, I am streaming on my other channel on Wednesdays. I also stream on Mondays most days, so if you are interested in more bug content, feel free to stop in over there. Check out the Alveus Clips page. One of the community members puts a lot of work into this and kind of get some of the highlight bits of the streams and of the collabs that you might miss, so check that out. Stick around for rounds. We check on the ambassadors one more time before we all head off to bed, and that is going to happen right now after I sign off. So thank you all again. I will hope to see you back here next week, same time, same place, if not before, on one of my streams. And one last plug, join the Bug Discord. We have an Alveus Bug Enjoyers Discord that if you have bug questions throughout the week, we hang out in there so you can come ask them and don't have to wait until next Wednesday to ask your questions. Goodbye, chat. Have a lovely evening, and I will see you back here, same time, same place next week. Bye!